Welcome to an example of integration using trig substitution. Before trying trig substitution though, we should make sure that basic u substitution won't work. So looking at our integral, notice how we might try to let u equal the integrand of 36 minus x squared. But notice if we do this, differential u would be equal to negative 2x dx, which does not fit the form of the integral. But because the integral does contain the square root of 36 minus x squared, which fits the form of the square root of a squared minus x squared, where a squared is a constant, we can use trig substitution and let x equal a sine theta. So we need to be able to recognize the form of the square root indicates which trig substitution we will use. For example, if the integral contained the square root of a squared plus x squared, we would let x equal a tangent theta. And if the integral involved the square root of x squared minus a squared, we'd let x equal a secant theta. So because basic u substitution failed, and it fits this form here, where a squared is equal to 36, and therefore a equals 6, we will let x equal 6 sine theta. And therefore differential x, or dx, is equal to 6 cosine theta d theta. Before we go on, let's sketch a reference triangle for angle theta. Notice if x equals 6 sine theta, then sine theta equals x divided by 6. So if we sketch a right triangle, and call this angle theta, we can label the opposite side x and the hypotenuse 6, and therefore this other leg would be equal to the square root of 6 squared minus x squared, or the square root of 36 minus x squared, using the Pythagorean theorem. Now let's go ahead and perform our substitution. We would have the square root of 36 minus x squared. Well, if x is 6 sine theta, x squared is 36 sine squared theta. Dx is equal to 6 cosine theta d theta. And the denominator is 4x squared, which would be 4 times 36 sine squared theta. Now let's begin to simplify. Let's first take a look at this square root. If we factor underneath the square root, we can factor out 36, which would give us the square root of 36 times the quantity 1 minus sine squared theta. And the square root of 36 is equal to 6. So we'd have the integral of 6, and then 1 minus sine squared theta is equal to cosine squared theta, and the square root of cosine squared theta is cosine theta. So we have 6 cosine theta times 6 cosine theta d theta divided by 4 times 36 times sine squared theta. And since 6 times 6 is 36, these two 6's simplify to 1, and so does this 36. So we can factor out 1/4, since the 4 is in the denominator. We'd have the integral of cosine squared over sine squared. Notice in this form, we might think to try u substitution, where if we let u equal sine theta, but notice that differential u would be cosine theta d theta, which does not fit the form of the integral because we have cosine squared theta. So let's go ahead and write cosine squared theta divided by sine squared theta as cotangent squared theta. Now in this form, we still don't have a basic integration formula that we can use for cotangent squared theta, so now we'll perform a substitution using a Pythagorean identity. So to review, looking at this identity here, we can replace cotangent squared theta with cosecant squared theta minus 1. And the reason this helps is there's an integration formula for cosecant squared theta, as we see here. So we can write this as 1/4 times integral of cosecant squared theta minus 1 d theta. And now we can integrate. So we'll have 1/4 times the quantity. Well, the integral of cosecant squared theta is equal to negative cotangent theta, as we saw in the previous slide. The integral of 1 would be theta. Then we have plus c. Let's go ahead and factor our negative 1 here. That would give us negative 1/4 times cotangent theta plus c. So here's our antiderivative in terms of theta, but we need this in terms of x. So now we'll perform a substitution for cotangent theta as well as theta, which will require an inverse trig function. So going back to our reference triangle, cotangent theta would be equal to the ratio of the adjacent side to the opposite side, which would be the square root of 36 minus x squared divided by x. Let's perform that substitution first. And then for theta, we'll use an inverse trig function. So looking at this equation here, if sine theta equals x divided by 6, then theta must be equal to inverse sine or arc sine of x divided by 6. So while we could use a different inverse trig function, let's use arc sine. So we'd have plus arc sine x divided by 6 plus c. And I think we'll go ahead and leave it in this form here. This would be our antiderivative in terms of x. I hope you found this explanation helpful.